Hello, I'm here to talk about deploying ArcGIS Enterprise in Amazon Web Services. My name is David Cordes, and I'm joined today by Kanika, Pankaj, and Subrod. Now, our agenda will go pretty quickly. The first thing we're going to cover is the introduction to the Cloud Builder. The introduction is to level set us so that we're all talking with the same terminology. Cloud Builder will introduce an easy, fast way to install ArcGIS Enterprise on AWS. And then we're going to go into our CloudFormation templates and an Elastic Kubernetes service. Both of those are new at 10.9. Now, I know we've had CloudFormation templates at previous releases, but there are significant changes there at 10.9 that you're going to want to hear about. So I would expect that a lot of you are familiar with this next section to some extent, but I want to make sure everybody is. And it probably doesn't hurt to have a refresher. Now, I'll be using the term base deployment a lot in this presentation. The base deployment is a combination of your portal, a hosting server, and a data store. And the data store can consist of several different subtypes, such as the relational data store, the tile data store, and the spatial temporal data store. Now, going over the architecture of ArcGIS Enterprise a little bit beyond what we're going to cover in this session, but do understand that if you're going to be using ArcGIS Enterprise, then this is the thing that you start with. The base deployment is where you start all of your architectures and you build off of. The other thing that we'll be talking a lot about are federated servers. And it's probably worth mentioning what federated means. Federated means that these servers share a security boundary with the portal, meaning that users who log into the portal are automatically signed into the federated servers, so that users don't need to be having to sign in multiple times for using multiple GIS server products. It also means that permissions are controlled in one place within the portal, and it simplifies the administration of your architecture as well. Now, when we talk about federated servers, we're talking about things like the GIS server, which provides, maps and geocoding and other things, the basic GIS functionality. But we're also talking about the image server, raster analytics, geo-event analytics, mission server, and notebook server. Now, some of these can be installed by themselves, but most of these require a portal to provide services to these servers. Now, I'm now going to just jump right in, like I promised, into deploying. And the first way I want to deploy, the one that everybody should know about, is the Cloud Builder. The Cloud Builder is the automation tool that makes it fast and easy to deploy both on AWS as well as Azure. Now, there's separate tools for AWS and Azure, but they provide the same functionality and purpose. They deploy ArcGIS Enterprise in the cloud. And I always recommend people start here first because this truly is the easiest and fastest way to get things going. Now, if you need more power or more flexibility, sure, you might not be able to use it. But I think after you hear about it, it's going to satisfy most people, I believe. Now, what does it do? It lets you deploy architectures, and there's two architecture options. You can deploy just ArcGIS server. So there's no portal, there's no data store, it's just ArcGIS server. Now, the other option is the full enterprise. And so this is the base deployment plus any federated servers you want. One of the nice things about the base deployment and federated servers is you don't have to give up high availability. We can pick a minimal kind of architecture where we try to minimize the cost, but it won't be highly available. Or we can set up a highly available architecture for you as well. That's what I'm saying. You're not giving up much when you're using the Cloud Builder because you get most of the architectural considerations that you care about. The other thing it can do is it not just sets up the ArcGIS Enterprise software, configures it, but it also sets up Amazon resources for deep integration into the cloud. One of those things it can do is it can set up an S3 bucket for you so that when users upload stuff to Portal, it will store it in S3's limitless storage capacity, highly durable, highly available storage option. It will also set up a DynamoDB database for you if you choose to put your ArcGIS server settings into. Now, if you don't want to use those options, we also let you store those things on a file server. It's up to you. Finally, we also set up databases for you using Amazon's RDS service. That's basically database as a service. So we can set up Postgres, Microsoft SQL Server. We can also set up Aurora using the PostgreSQL interface. And we'll automatically register those databases with your ArcGIS server for you. It's really slick. To get a better sense of this, I'm going to ask Kanika to show you the cloud, how you can use the Cloud Builder to deploy a base deployment.
Hello everyone, I am Kanika, and today I am going to give a demo on one of the deployment scenarios using ArcGIS Enterprise Cloud Builder for AWS. So this is how the application looks like. This is the login screen. You can either log in using your Amazon key credentials or an AWS profile. I already have an AWS profile stored on this machine and I'll use it to sign in. Once I log in, I see my deployment screen where my existing deployments are listed. Today we are going to create a new deployment, so let's click on this Add Deployment link here. Now the application is asking what type of deployment do you want? Do you want an ArcGIS Enterprise or a standalone ArcGIS server? As in releases prior to 10.7.1, we can still create ArcGIS server, ArcGIS image server, and ArcGIS geo event server deployments using the standalone ArcGIS server option. But going forward, we do have an option to create complete ArcGIS Enterprise deployments. So let's choose this option and click Next. Now the application is asking what kind of deployment do you want? Do you want a single machine based ArcGIS Enterprise deployment or a highly available one? The application also gives us the option to create many different kind of architectures. Let's choose single machine based ArcGIS Enterprise deployment today for demo because it's the most common and most simple deployment scenario for 70 to 80% of our users. Now we need to give the configuration parameters for our deployment. Which region we want our deployment to be? What is the operating system? And also give a unique deployment name. We also need to provide the network details like VPC. I already have a VPC and I'm selecting it for my deployment. I need to give a key pair and then move next. Now the application is configuring the elastic IP. We need to specify a site domain and an SSL certificate associated with this domain. A key thing to note here is this validate feature. It validates the site domain name with respect to the elastic IP. It can help save many hours of troubleshooting later on for the site domain name related typos and errors. When I click on this validate link, it validates that yes, the site domain name exists, and then let me proceed from here. Now I need to provide the ArcGIS credential, the primary site administrator account, username and the password. Since I chose Windows as my operating system for the deployment, I need to provide the run as username account, the username and the password. I click on next, and now we need to specify the machine requirements. What kind of instance type do we want for our deployment? How big of a machine? What would be the drive size root? We also need to provide the license files. Portal license file to authorize portal for ArcGIS, hosting server license to authorize ArcGIS server. A thing to note here is this option that we can upload the license file from the physical machine location into the S3 bucket, and if it's already done, then we can select it from the application itself. Also, we need to specify the configuration store as cloud store or file system. What does this mean? This means that our ArcGIS server config store and portal content store is going to reside in the S3 bucket or the EC2 instance itself. So after giving all these details, we can move from here and click on next. Now I see that a summary is generated for the deployment. I can verify that yes, these are the inputs that I had given and all the key features are there which I require for my deployment. When I feel satisfied that yes, I'm ready to create a deployment, I can click on this button, create, over here to start the deployment process. Now this deployment process takes few hours, but to show you how it looks like once it completes, I have created a similar deployment. The deployment is listed on my deployment screen, and when I expand on it, I can see the key features and output of the deployment. My ArcGIS Enterprise site is ready, and if I click on this link here, I can access the site and start working on it. Thank you.
Thank you, Kanika. So as you saw, Kanika showed the Cloud Builder GUI, which shows you the simplest interface possible for getting ArcGIS Enterprise up and running in the cloud. What often people aren't aware of is that it also has a command line interface. All you need to do is provide a JSON file, and you can use the command line to script and automate your deployments as well. Now, one of the things about writing JSON is it can be not a lot of fun sometimes. Well, one of the things you can do is you can go in the Cloud Builder, go through, answer all the questions through the wizard, and save that configuration in a JSON file. And so this is a really nice way of setting up and recording and storing information about your architecture in a file. The next area I want to cover are CloudFormation templates. Now, as I told you at the beginning of the session, you may have used CloudFormation templates at previous versions. At 10.9, we made a big jump. There's a lot new here, and there's some stuff that you may have to relearn. Before I get into the changes we made with CloudFormation, I want to talk about the motivations. What we wanted to do at 10.9 was allow more people to automate on the cloud. We have a lot of people who are automating on the cloud, but there are some people who are encountering obstacles and challenges that prevent them from automating. And so what we wanted to do is remove barriers at 10.9. An example of one of those barriers is the gold image challenge. And there, a lot of our customers, especially those in highly secure environments, have to use an image that's from their own environment. They can't use an AMI produced by Esri. They can't even use an AMI that started its life as an Esri AMI and then was modified. And that's kind of unfortunate because a lot of our automation, or all of our automation, requires the use of an Esri AMI or something derived from it. So that's been something that we've been wanting to take care of for a while. And you'll learn a little bit more about that in a minute. Another thing is we sometimes get people who say, well, I see the architectures that you do provide for ArcGIS Enterprise, but I want more flexibility. And at 10.8.1 and prior, each architecture is a CloudFormation template. And so what we wanted to do was not to produce 100 more templates. We wanted to provide an easier way for you to get the architecture that you wanted. You know, an example of this is sometimes it's a best practice in organizations to separate all the tiers. So portal needs to be on one set of machines. Server needs to be on another. Data stores need to be on another. And maybe you want the relational data store on a different machine than the tile data store. Maybe you want them on the same machine. We want to give you all of that flexibility. And then finally, you know, people always want better upgrades. Now, one of the things with upgrades a lot of times is that you get locked into technology. If you've been using our upgrade technology with ArcGIS Enterprise on AWS since 10.4, well, what you've noticed is at that time, the only option from AWS were ELBs, of the Elastic Load Balancer. Since then, Amazon has introduced, for instance, new load balancers. And you haven't been able to take advantage of them as you've been upgrading because our upgrades kind of have locked you in. So that's something we care about and want to do something about. Finally, we have a lot of customers who are very happy and they want to stay happy. They don't want us to make a lot of changes to their existing workflows that are working fine. So if you're in this camp, listen to these changes and hopefully they'll keep you in that happy camp. So our goals were the following, tied to these requirements. We wanted to allow deployments from clean images. We wanted to allow flexible architectures. We want to have better upgrades, and we want to keep our happy customers happy. Let's go through what we've done and how we've achieved these goals. The first is at 10.9, we're going to allow you to bring a clean image. So you can start with either an Ubuntu image or the Windows Server 2019 image on AWS, and you can install or you can use our automation deployment and CloudFormation templates to install at runtime. I want to emphasize that this doesn't mean that you have to do it this way. We're just giving you additional options. I think the other thing that gets asked a lot when they see this slide is, well, can I use my organization's hardened Windows image and deploy on that? And the answer is not yet, but we hear you. That we hope that will be coming soon. So let's talk about how this works at 10.9. So if you need to use one of Amazon's clean images, then the way it works is you run our CloudFormation template. Our template will spin up an EC2 instance. And then what it will do, it will download the software from a software repository. This is not something you need to manage. Don't worry about it. We'll download it. And when it downloads, we will install the software and we will continue. Now, our automation technology is smart. So if it realizes that the software is already installed, it doesn't do anything. It does not waste time trying to install the software or download it. It just skips those steps and goes directly to configuration. Now, one of the interesting things that we found in this new architecture is that you would think this would be slower, right? Because you're downloading, installing the software. How could that be faster? Well, that's true. But as we've been working with this architecture, we've been able to parallelize more things. So if you have a highly available architecture, you will actually find that even when you're downloading the software, it's faster than 10.8.1 because we are spinning up more machines in parallel and doing more things in parallel, which just increases the performance tremendously. Now, I hesitate to get into this part, but I feel like I need to. I need to explain a little bit. This is on how we make our software, how Esri codes our AWS CloudFormation templates. And it's important because these are things that have been impacting your user experience from an upgrade perspective. What we've done over the last, since 10.1 essentially, is we have code that upgrades your infrastructure, sets up your infrastructure, and we have code that configures ArcGIS Enterprise. And that code has become intermingled and entangled. And what that means is it's been really hard for us when we've upgraded to introduce new Amazon technologies as part of our automation stack, because that same code that launches you clean also upgrades you. And so that code entanglement really has been a challenge. So at 10.9, we've taken a fairly big step and we've separated those. So now the code that deploys the Amazon infrastructure is cleanly separated from the code that configures ArcGIS Enterprise. And so we expect to give you more flexibility when upgrading and to give you a simpler upgrade experience. The next thing to talk about is our 10.9 templates. This is maybe the biggest change if you've been using our software. This is what's going to give you flexible architectures. Prior to 10.9, we have had a template for every architecture. We've had a template for highly available deployments on Linux, highly available deployments for Windows, all-in-one machine for Windows, an all-in-one machine for Linux. And when you ran that single template, you got a full architecture. The problem is there's so many permutations and combinations that are possible that if we continue that pattern, we would have hundreds of templates. It'd be really hard to determine which was the right template for you. So we've taken the opportunity that we've had to rethink it. At 10.9, our templates are building blocks, Legos, if you will. Our templates will give you a template for setting up your VPC. We kind of already have that. A template for setting up your load balancer, a template for setting up your RDS database, a template for portal, a template for server, a template for the data store, a template for our mission server. So each of these pieces will be its own template. Now that means if you're using CloudFormation, you will be able to set up these things separately. And then we also have a template for federating them. And that federation template sticks, like we said earlier, your servers with your portal and brings them into the same security boundary. Now, this is really powerful. And we're really excited about it because hopefully this allows anybody who said, I don't see my architecture among the architecture for CloudFormation to now say, I can choose that automation, I can get in and make life easier for myself. Now, one of the things we said is we want to make minimal changes to our happy customers. And for these radical changes that we've made, we've been pretty good at maintaining them. In fact, if you liked our CloudFormation template for getting a highly available system on Windows, we still have it. We didn't make those templates go away. If you're using Cloud Builder, you can do exactly the same things you did in Cloud Builder, except one thing, and that's the upgrade. And we'll talk about upgrades as a separate thing. But for the most part, you haven't lost any functionality. The interfaces are the same in Cloud Builder. They're very close to being the same in CloudFormation templates. The big thing that we need to talk about are upgrades. So, like I said, we entangled our upgrades at previous releases, and so we've made a clean separation at 10.9. And so we can't provide you automated CloudFormation templates that upgrade you using CloudFormation. And because that's how Cloud Builder worked, we can't do that either. Now, that doesn't mean you can't upgrade. Of course you can upgrade. We have two different ways you can upgrade. You can upgrade just like you could on-prem. If you're using our software on premises, you can download the software, install it, run the upgrade wizard, and then you have upgraded your portal, your server, and your data store. Of course, that option is available to you. The other thing that's available, and we have documentation for this, is you can upgrade using our Chef scripts. So some of you more advanced users may be aware that the way we configure our software on AWS within the running instances is through Chef, our Chef automation technology. And so we have JSON files on all of our images, all of our instances that say this is what this machine should be. And you can go in, modify that JSON file, and it will perform the upgrade for you. So you still have automation options. If you've had an existing deployment and you're like, I really love this stuff you've done at 10.9, I want to get into it. Well, what you would need to do is first upgrade to 10.9, then launch your architecture at 10.9 using the new template, and then use the WebGIS DR tool to migrate your content over. Now, to make some of this more concrete, my colleague Pankaj will now show you how to deploy with CloudFormation templates.
Hello everyone, I am Pankaj. In this demo, I'm gonna show you how to set up a distributed ArcGIS enterprise deployments purely using CloudFormation templates provided by Esri. Here, in the interest of time, I have pre-created a distributed ArcGIS enterprise deployment. This deployment has VPC with two public subnets in it. It contains an application load balancer. Here, I have configured portal for ArcGIS, ArcGIS GIS servers, ArcGIS relational data stores, and ArcGIS notebook servers on separate set of machines in highly available mode. In the end, I have federated ArcGIS GIS server site into portal as a hosting server and federated ArcGIS notebook server site into a portal as a notebook server. In this diagram, each rectangle represents an individual EC2 instance. I'm calling this as a distributed ArcGIS enterprise deployment because I have configured various ArcGIS enterprise components like portal, server, data store on individual machines. Just to let you know, this is just a conceptual diagram for understanding the deployment architecture. It does not represent all software components configured on each EC2 instance. Now let me show you how I have created this deployment from scratch using CloudFormation template. Before we jump into creating the deployment, we need to do some preparation work. Here in AWS S3, I have created this bucket, and inside this bucket, I have uploaded my ArcGIS software licenses and SSL certificate. It's entirely up to you how you want to create your folder structure in this bucket, or you can put your license files and SSL certificate directly in the root of the bucket. Henceforth, this bucket is termed as a deployment bucket. Then I have imported SSL certificate into AWS Certificate Manager. You can refer to AWS documentation to know how to import the certificate into the Certificate Manager, or you can use Esri Cloud Builder CLI tool with the prep command for importing the certificate. Then I have configured all my passwords into AWS Secret Manager. So how you store the password is choose the secret types as other types of secrets and enter your password in plain text and continue this wizard until you store a secret. So in CloudFormation template, instead of entering a password in plain text, I always refers to the secrets ARN. For creating ArcGIS enterprise deployments in AWS, the first step is to create a VPC. So here I have already created a VPC using the CloudFormation template with these input parameters. These are the output of the VPCs which are used has been used as an input in majority of the subsequent stack. So once you create a VPC, your deployment architecture looks like this. Then the next step is to create a application load balancer. This is my application load balancer stack I created with these input parameters. This SSL certificate ARN is the same ARN for the certificate I imported into a AWS certificate manager. So once your load balancer stack is successful, it spits out a load balancer DNS name. The next step is you need to map this load balancer DNS name with the domain name of your choice into your DNS. So here I'm using route 53 is my DNS, and I have mapped this load balancer DNS name with the domain name of my choice. Then the next step is to create a highly available portal for ArcGIS deployment, ArcGIS GIS server and ArcGIS notebook server. Here ArcGIS server and notebook server has been configured in auto scaling group. I have created this portal, ArcGIS server and ArcGIS notebook server stacks in parallel. Let me show you these CloudFormation stacks. So here are the input parameters for my portal stack. Here are the input parameters for my notebook server stack, and here are the input parameters for GIS server stack. Let me quickly show you how I have created a portal stack. So here I am navigating to my portal template. I am picking platform type as Linux. Here I am entering a VPC and subnet IDs, which are the output of the VPC created in the step 1. Then I need to enter a domain name which I set in route 53 in previous step. Then this is the load balancer name. This is the output of application load balancer stack created in step 2. Then I need to enter my deployment bucket name. This is my deployment bucket. I need to enter a portal license path in the deployment bucket. This is my portal license file. This is my user license type ID. This is my administrator username, administrator password. Administrator password I can directly get it from secret manager. So here instead of writing the password in plain text, I'm entering the ARN from the secret manager. I can pick any content store. Then I need to enter a web adapter name. I need to pass the path for my SSL certificate in the deployment bucket, and I need to retrieve a SSL certificate password from my secret manager. And I can click on next and continue creating these stacks. So one thing to note here is in all this three stack, this site domain name and ELB DNS name is common. Only the difference is the license file and the web adapter name. Okay, so the next step is to create a highly available ArcGIS relational data store. This data store stacks configures the relational data store in primary and standby mode. Also register it with the ArcGIS GIS server side during stack creation. Let me show you this relational data store stack. I have used these input parameters for creating this stack. Let me quickly show you how I have created this stack. So I am navigating to the appropriate data store template here. Then these rest all are the standard inputs. Here in this particular section, I am entering the site administrator password of the ArcGIS GIS server site. For password, I am referring to a secret ARN. Here, I can choose any instance ID of ArcGIS GIS server participating in the site. So here I can pick this one file or this one. Then here I have selected the type as relational. I just left the remaining parameters as default and continued with the stack creation. Now the remaining steps are to federate this ArcGIS server into a portal for ArcGIS as a hosting server, and federate this ArcGIS notebook server into a portal for ArcGIS as a notebook server. To achieve this federation operation, I have used a federate server stack. Let me quickly show you those stacks. This is my federate GIS server stack with these input parameters, and this is my federate notebook server stack. Let me quickly show you how the federate stacks works. Here I am navigating to the approved stack. Here I am picking as a hosting server. Since I am configuring GIS server into a portal as a hosting server, I need to enter the ArcGIS server site administrator username. Here for site admin password I can use ARN. Here I need to enter ArcGIS server services URL. You can get it from output parameter of the respective GIS server stacks. This URL is also used as an administration URL. As I explained previously, you need to pick the appropriate server instance ID. This is a portal administrator name. Here I'm using the same password, and then I can pick either this standby or primary portal instance ID and click on continue creating the stack. Once the stack is created, it will federate the respective server into a portal. So at this stage, we have successfully configured a distributed ArcGIS enterprise deployment into AWS. So to summarize the deployment, we did this prep work and we executed these 6 steps. Here I have listed down the stacks under each step. I hope this demo is useful to you in quickly getting started with creating ArcGIS enterprise deployments into AWS. Thank you.
Thank you, Pankaj. I now want to cover deploying ArcGIS Enterprise on EKS. So you may not know this, but ArcGIS Enterprise is now available on Kubernetes. This is a new platform at 10.9. Now, we've done a lot of new implementation, but the way to view it is you're going to get the same functionality essentially, but they're just different platforms. So we have ArcGIS Enterprise on Windows, and we have it on Linux, and now we have it on Kubernetes. This is worth learning about, and I would encourage you to watch our other Developer Summit presentations, because I'm not going to get super deep into it. I'm just going to cover high level the basics about how to get it running on AWS. So the first thing is we're running it on EKS, which is Amazon's Kubernetes platform, the Elastic Kubernetes service. Now, there's EKS can run using nodes that are managed that are run in your account as EC2 instances, or they can run on what's called Fargate. Our implementation runs within nodes in your account, not the Fargate yet. So EKS, what it does is it spins up nodes in your account. It manages the Kubernetes on them so that you don't have to run the software or update it or do other kinds of stuff. And those nodes provide the machines on which your pods run. Pods are containers or groups of containers that work together. Now, our implementation utilizes Amazon infrastructure. So the load balancers that your web traffic is going to come through, they're implemented in Amazon. They're Amazon's load balancers. We need a place to store stuff, and that will be through what's called persistent volumes. The nice thing about Kubernetes is our software just needs to know their persistent volumes. We don't need to know what technology is backing it. We've done a lot with EBS volumes, but you could back it with other types of storage as well. And then finally, your pods, your containers, will be running on EC2 instances as Kubernetes nodes. Now, it's different than our software on Windows and Linux in that there are no setups. There's no setups to run. Instead, we start up container images. And those container images are distributed through Docker Hub to all customers. Now, you're welcome to push them into your own Docker registry, and we can connect to anything. But we distribute them through Docker Hub. Now, to actually get things running, you're going to use a deployment script. It's a bash script, essentially. So it does need to be run on Linux. So now when you run this, it's going to create the AWS resources we talked about a minute ago. And then it bootstraps some of our core pods. So it's going to start up a few pods, and it's going to just so that you can then run the create site utility that will then spin up all your other pods and give you a fully working ArcGIS Enterprise. To get a really good idea of how this works, Subrat's going to walk us through how you deploy ArcGIS Enterprise on EKS.
Hello, my name is Subrat Bora, and I work as a product engineer for the ArcGIS Enterprise development team. I focus on the development of ArcGIS Enterprise on managed Kubernetes services, including Amazon EKS. In this demo, I'll show you how to get up and running with ArcGIS Enterprise on Amazon EKS. It's a two-step simple process: deploy and then configure. The first step deploys 4 initial containers, and the configure step pulls rest of the containers and then performs necessary configurations to get ArcGIS Enterprise ready to use. Before diving in, let's have a look at some of the prerequisites for deploying ArcGIS Enterprise on EKS. First, you'll need an AWS subscription and an EKS cluster. I'll not go into details about how to create an EKS cluster. AWS has some great documentation on how to create a cluster and a node group. Second, you'll need a client workstation with a bash shell which can connect to the EKS cluster. You'll need AWS CLI, kubectl command line utility, ArcGIS Enterprise deployment scripts, and Esri licenses on the client workstation. You'll also need access to the Esri containers hosted on Docker Hub, which will be provided by Esri, and a namespace in the EKS cluster. We install all our workloads in a dedicated namespace to logically separate ArcGIS Enterprise from other workloads in the cluster. Please check our system requirement pages for more details on prerequisites. We'll discuss some of them as we go. Here's my EKS cluster. I have a node group with 6 nodes. Here's my workstation terminal with kubectl installed. I have the deployment scripts downloaded in this location. Verify connection to the EKS cluster by simply using kubectl version command. I can see the EKS cluster version. I can also see the 6 nodes by using kubectl getNodes command. Now you are ready to deploy ArcGIS Enterprise. Simply run the deploy script and it will ask you a few questions related to your deployment. The first question is, do you want to provision a cloud load balancer? ArcGIS Enterprise uses an ingress controller to allow incoming traffic to the cluster. This ingress controller is also a dedicated one designed to work with only ArcGIS Enterprise. On a managed cluster environment like EKS, the deployment scripts can set the service as a load balancer service. This means a cloud load balancer will be created automatically and target group will be configured with the backend. I'm going to say yes here. Okay, text Y as an input. Next, type of the load balancer. I'm going to use an AWS NLB, which will be an external facing load balancer. Next, load balancer IP. This applies to Azure AKS only, where the load balancer can be assigned with a pre-created public IP. I'm simply going to hit enter. Next, namespace. Let's create a namespace called Dev Summit. Enter the namespace here now. So next question is about container registry. The containers are hosted on Docker Hub. I'm going to enter Docker Hub as my container registry and the credentials that I have. Next, you'll need a fully qualified domain name, which will be used to access the ArcGIS Enterprise deployment. You can create the actual DNS record later, but you'll have to decide the DNS before this step. I have a domain registered called demo-gis, and I'm going to use a host name DevSummit. So my FQDN will be devsummit.demo-gis.com. Next, context path. I'm going to use AWS as the context path. Next, node port for the ingress controller service. I'll let Kubernetes assign any available port with the node port range. Hit enter. Next, certificate for the ingress controller. You can use automated certificate management workflows with something like Cert Manager by selecting option 1, or you can enter a certificate file here. I'm going to use a PAM format cert and the key file. And then all these properties will be saved in a file and showed to you. You can use this file later to deploy again without entering those values again. Or you can also automate the deployment with a template properties file like this one. Now, when we hit enter, it'll start deploying the initial setup containers. Now let's see what's happening in the namespace once this script starts deploying. As you can see, a load balancer service was created with a public endpoint, which is basically a record, and 4 initial pods were deployed. Now you can create the DNS record for the FQDN that you defined earlier. It will be a CNAME record pointing to this A record of the load balancer. Once the DNS record is in place, you can proceed to the configuration step. Configuration can be done using the scripts that we provide or interactively using a browser. Let's see the browser way. Once your DNS record is created, simply copy this URL and paste it in your browser. And here we go. We have the configuration wizard in our browser environment. Click Continue, enter the license information, click Next, fill out this form about username, password, email, all the fields. Click Next. Now you can define the persistent volumes for the stateful pods. You can use the default GP2 storage class that comes with the EKS cluster to create persistent volumes dynamically, or use your own storage class with your choice of available disk types. You can also use different types of storage class individually for each stateful workloads. Just wanted to mention here that you can use statically pre-created persistent volumes as well. In that case, we use label matching to bind those volumes. Now I'm going to use the default GP2 that comes with EKS cluster. I'm going to use the same storage class for all the persistent volumes. Now you can click Finish to create the ArcGIS Enterprise organization. This process will take approximately 20 minutes, and after 20 minutes, you'll get a ready-to-use ArcGIS Enterprise environment. I just fast forwarded the video and now I have a ready-to-use ArcGIS Enterprise environment. If I click on this URL, it's going to take me to the portal's home login page. Thank you for watching.
Thank you, Subrod. That ends our presentation on ArcGIS Enterprise on AWS. Hopefully you found that there's a few good ways to automate the software. If you do have any questions, please feel free to reach out. And I'd ask that you provide any feedback for the session by using the survey link directly below the video. Thank you.